All right, we are looking at lesson 46 today. We're looking at more radical expressions. For some reason, I feel like this is review. Have y'all not done these before? Just without the 90, the square root of 90? Okay. But it's basically the same thing, right? Okay. What are you going to need to do first? Okay, and then what? Yeah, and then plus what? 3 squared roots of 2 over what? What am I going to multiply this one by? Does that make sense? All right, for the square root of 90. How can you factor 90? How does 9 factor? How does 10 factor? So we have 2 times 3 times 3 times 5. Does that make sense? Any questions on that so far? Okay, so what happens to this first term? Over 2. And then plus what? What happens to the minus square root of 90? Yep. Okay, what is the common denominator? I'm running out of room. What is the numerator going to be? 15 square root of 10 over 10. Does that make sense? What would the next term be? What about the last term? 30 square root of 10 over 10. Does that make sense? We want to make it so we can add them all together easily. Any questions so far? Okay. So 10 is our denominator. Does the square root of 10 change? Okay. 15 plus 6? 21 minus 30? Negative 9. And that is your actual answer. You see how that works? Yeah. If you can reduce the 9 and the 10, those two numbers, you would want to. Not much different than what you've already done, right? All it's doing is adding a term. These three won't always have the same square root. Like they all have square root of 10. Sometimes they'll be different ones, okay? So if they're different, do you combine them? So you would leave it as these two together and then whatever that one was, if they were different square roots. Not fractions. The square roots are like variables. So you can't combine like x and y's.
Teachers, pardon the interruption. All girls basketball need to report to the gym right now. Thank you.
Good grief. Oh no.
The 90?
Uh-huh. That's fine. As long as you can get to not 3 square roots of 10, that's fine. I doubt she'll be able to hear you even still. All right, let's look at another one. Yeah, if you can do it by yourself, go ahead. Do you agree? Any part that I need to go over? None? Squared what? 84. This is just 6. So I want to make it over 14. So 6 times 14 gives me 84 over 14. Any other questions? None? Okay. All right. These are different. They're radicals under radicals. You want to convert your radical notation to fractional exponent notation. Like the square root of 2 is the same thing as 2 to the 1/2. Does that make sense? You remember how to make them into exponents? You don't remember? What's the number understood right here? What's the understood number here? 1 over 2, 1/2. We've gone over this before. Yeah. Something like that. Everything, they're all going to be numbers, not variables. But you want to convert every radical into fractional notation. Okay? Yeah, you want to get rid of your radicals, and then you're going to use rules of exponents to simplify. You have to be very careful on these. They're not difficult, but they're very easy to make a mistake if you add when you're supposed to multiply, or vice versa. What do you do to your exponents on this one? So it'd be x to the what? What do you do here? You add them. Okay? You got to pay attention. You have to pay attention to your rules of exponents. When you have a power raised to a power, you multiply. If you are trying to multiply, you add your exponents. Okay?
Wait, where's the plus sign?
There isn't. When you're multiplying, you add your exponents. What's x squared times x to the 3rd? X to the 5th. You add your exponents. Okay? I just made it up. Y'all remember those 2 rules? You have to know how to use those. That's like what most of these problems are going to be.
So that's not an extension of the problem?
No, those are just 2 different examples. No, it was just two different rules. So we've got the square root of 3 times the square root of 3. A radical under a radical. No, you haven't done these before. Instead of the square root of 3, you start with your innermost radical and make it 3 to the 1/2. Does that make sense? Okay. What am I doing with these 2 3s? Multiplying them. So what do I do with the exponents? What is the exponent here? So I keep the base the same. 1/2, which is what? 3 halves. 1 plus a half is 3 halves. The x stays as an x. It doesn't change. Does that make sense?
Oh, because it's got a half. I got you.
Do y'all see how that works? Okay. What's 1 plus a half? 1 and a half. And then make 1 and a half. Two over 2 is 1 plus 1/2. 3/10. What do I have to do with this radical now? How do I get rid of it? All of that to the what? All of it is being square rooted, right? So all of it is being raised to the 1/2 power. Three to the what? 3/4. Because all of it is being square rooted, and so all of it is being raised to the 1/2. A power raised to a power, you multiply. Any other questions? What part? From here to here? Or from here to here? Then move. If you can't see, you need to move. Or you can move to a different desk. Any other questions? You'll get a decimal. 3 to the 3/4 is going to be 2 point something. Or 1 point something. What's 2 halves times 1/2? 3/4. Because it's a square root. So it's all raised to the 1/2. Any other questions on these? Okay, let's look at another one. What's different? Cube root. Same thing, same concept, yes. Can you simplify this cube root before you do the square root? Because this is on the inside. You always start with the inside. We'll get there. You keep the outer radical the same. Instead of the square root of 3, what do I write? It's what? 3 to the 1/2. Does that make sense? What happens to these two? You multiply them, and how do you multiply them? Only add the exponents. So it stays as 3. What's the exponent here? 1 plus 1/2 is 3/2. Does that make sense? Okay. No. It will. They could change it to 9 times 3, but can you write 9 as 3 to the something? Can you write 9 as 3 squared? They'll do that later. But if you have one where you're multiplying, there'll always be a way to make them the same base. Any other questions so far? Okay, now what do we do? Multiply what by 1/3? Where'd the 1/3 come from? The cube root. 1 over 3, because it's the cube root. Yes. Okay.
Like, change the 3 and 3 over 2 to 2 square roots of 3 cubed.
Huh? Say that again.
Change that.
Uh-huh.
2 square roots of 3 cubed. Right? Yeah.
This, you could change it to the square root of 3 cubed, and you'd have the cube root of that. But you don't want to do that. Yeah. You don't want to change this back into a radical. I changed this radical into an exponent. The cube root of anything is whatever it is to the 1/3. So we took it and then we raised it to the 1/3. Does that make sense? Okay. We're taking radicals to exponents. We don't want to go back to the radicals. Okay. Any other questions to this part? Do you add or multiply? Multiply them. 3 to the what? Yep. You multiply them. Only when they have the same base do you add them.
When you keep the 3 the same.
Yeah. Mm-hmm. The base doesn't change. The 3 stays the same. Any questions on this one? Yes. Anything? Okay, let's look at another one. They'll also use variables.
Wait, is that?
It's the square root of x squared, or no, x cubed y squared times the cube root of xy. No, they're two separate radicals. Does that make sense? So we want to make the x into some, instead of having a radical, we want to make it into where it has some kind of fractional exponent. 3 over what? 3 over 2. And then y over what? Why 1? 2 over 2. It reduces to 1. If you leave it as 2 over 2 for now, that's fine. It doesn't really matter. For this one, x to the what? Does that make sense? Can we leave our answer like that? We need it to be one x term and one y term. I mean, like, not 2 of each, okay? How are we going to combine these? Okay, so instead of 3 halves, it'll be, and then plus 2 over 6, right? Does that make sense? And then what will I do to add these? Does that make sense? And that whole thing is your answer. Mm-hmm. Yeah. 1 is 3 over 3. Do y'all see how these work? Any questions on these? None? Okay.